Hello guys, it's the Teen Tutor back again with a math video. So today we're going to look at circle geometry, and with all that being said, let's just get right into today's video. So it is said that we need to calculate with reasons the size of angle R1, and this is our angle R1. Now, this it is said that it's also our center. So I didn't I cropped out the information that was there. Okay, so O is our center, and one thing you guys need to know is that the angle which is formed by the diameter, this is our diameter Y. This is because it is passing through the center. So the angles which is formed through the by the diameter in this on the circumference, that angle is always a 90 degree. Okay, let me, you see this, this is the angle that my diameter subtends. It's a 90-degree angle. So it's simple as that. So this is my diameter. Okay, this is my diameter. The angle that my diameter sort of like subtends, it's a 90-degree angle. So that means that you're going to say, oh, okay, so now I have a clue. So that means that R1, angle R1 plus 51 degrees, it's equals to 90 degrees. And according to, is it caps or what? According to I think it's the examination guideline or what, it is said that you guys need to use the following reason: angle on the semicircle. You need to use this reason, not the angle subtended by the diameter. But if you guys, or maybe the best way is to ask your teachers first. Okay, so then obviously you're gonna say, okay, angle R1, it's equals to 90 degrees minus 51 degrees, which is equals to, I think it's 39 degrees. I don't have my calculator, I don't know what I was thinking. I think it's 39. Yeah, it's 39. So it's 39 degrees. So that is the angle of R1. So the trick that I use every time when I'm doing a circle geometric question, besties, is to always write down my answer. Let's say angle here, they said angle R1, so I substitute the value of angle R1 once I have found it. So that is my favorite way of doing it. Okay, now let's look at 8.2.2. It said that we should find angle O1. Where is O1? Oh my gosh, this is angle O1. So this angle O1 is angle at the center. So there is this theorem which states that the angle at the center, it's always twice the angle at the circumference. But that angle, that's really important, it needs to be like subtended of some sort by the same arc. Okay, so I know some of you are like confused and like, girl, what's happening? I got you. So let me just firstly erase this. Don't worry, I'm gonna still write the 39 here, and then I'm gonna just do this here. Okay, so which one is our arc now? So our arc is PQ. That thing that I drew, it's an arc. Okay, so looking at the angles that it forms this angle at the center. It formed this angle, and it also at the same time formed this angle but at the circumference. So this is where the theorem which states that the angle at the center is twice the angle at the circumference comes in. Okay, so we are asked to determine the angle of O1. So what you need to know is that every time when it looks like that, you need to do it like this. Okay, let me just show you guys. There are three scenarios when it comes to angles at the center, twice angle at the circumference. Guys, I told myself that I'm going to be only doing this past question paper, but because okay, let me just do it. This is my little ugly circle. So let's say we have a center here, and we have something like this. Every time when you draw using a pencil in the exam room or anything, what you need to know is that the angle here is twice the angle here. Okay, so this is the first scenario. Now looking at the second scenario, let me just say here we have 2x and here we have x. Okay, so second scenario is when it's like this. this is the center, and then you see it is still subtending. To subtend is like, I don't know how to say it. It's like to form, but it's like elongation of some sort. Yeah. So that means that still here is gonna be 2x, and here we're gonna have x. Okay. And in the last scenario, it's when we have it like this. Oh, this circle was a lot better. It's a lot better. This is my center, even though it doesn't looks like one. Even though it doesn't look like it's not looks. Okay, let's say we have something like this. Correct. Yeah. So what you need to know here is that the angle formed here is twice the angle formed here. So it is still the angle at the center twice angle at the circumference. So here we're gonna have, let's say, x. Obviously here we're going to have 2x. Not this angle. Not this is where most people get things wrong. Not this angle, but the outside angle. So these are the three scenarios when it comes to angle at the center is twice the angle at the circumference theorem. Hope you guys have understood it. I really hope you guys have understood it. If you haven't, just comment down below and I'll make obviously a separate video for all the theorems. Not a separate video, separate videos. Okay, so now let's find angle O1. So obviously you're gonna say, okay, O1, angle O1, it's equals to 2 angle R1, which is equals to 2 multiplied by 39 degrees. And then what is going to be a reason angle at the center. So I'm gonna write that down. So equals to, what is 2 times 39, guys? 9 plus 9 is 18. So it's gonna be 3 plus 3 is 6. So it's gonna be 1. No. Hey guys, 9. Okay, let me just do it here. 39, 39. 9 plus 9 is 18, plus 1, 3 plus 3 is 6, plus 1 is 7. Okay, so it's goes to 78 degrees. Sorry, I don't have my calculator. Please, sorry. Now we are asked to determine angle Q1. Oh, it's Q1 now. So we are asked to determine angle Q1. So let's just write down our 78 now. Is 78 degrees. So what is angle, where is angle Q1? Oh, this is angle Q1. I really love this one because I can already see like the steps that are going to use to find angle Q1. So I said that this is my center, and the line drawn from my center to the circumference is a radii. So we have a radius and the radius. So that means that is this radius and this radius are equal. The radiuses are the radii is radii whatsoever, but it's like this. When there are many, they are radii. They are radii. I'm now an Indian. They are radii. I love Indians and I love their maths. But okay, let's continue. Because I also like, oh, let me not talk too much. Okay, so let's find angle Q1. So I told you that these lines are equal because they are radii. That means that the angles are equal. Remember the isosceles triangle that you guys learned in grade 4, grade 2, grade R? That is the one. Okay, so what you're going to say, you're gonna just say that, okay, Q1, guys, I'm sorry, you're just going to say, okay, Q1 it's equals to P2, and then you're gonna say the reason of isosceles triangle is not like isosceles triangle, because you are given the opposite side. You need to know the reason. It's just that I have forgotten the reason. I'm going to be real with you, but it's something like opposite angles equal side, or opposite sides equal angles. It's just that there are some conditions that have to be met first. Okay, so I also advise you guys to go to your teacher and ask for the reasons. Okay, because what I do in my channel is not like to teach completely, but to help or to guide my fellow learners here and there. Okay, so if they are equal, that means that you're going to say, okay, P1 will be equals to Q1, obviously. So you're gonna be left with Q1 plus Q1 plus 78 degrees will be equals to 180 degrees. Why am I saying that? This is my triangle. Okay, guys, I'm coming. Sorry, guys, I'm back. So that means that because these are like terms, is going to be 2Q1 plus 78 degrees will be equal to 180 degrees. So 2Q1 will be equal to 180 minus 78. That means that hey guys, the math here is going to kill. It goes to 102 and divide by 2, simply my little baby Q1 is equals to it's close to that number that you get when you press it on a calculator. So bye guys, I hope you guys have enjoyed this video.